Hey guys, welcome back to Pre-Calc 12, Chapter 1, Function Transformations. For Lesson 1.2, we're going to be learning about the effects of reflections and stretches for graphs. There are only two main learning targets for this section. You want to know the two main reflections from graphs, the reflection over the x-axis and the y-axis. And you want to know the effect of a horizontal or a vertical stretch that occurs on your original graph. Before you get started, I'm going to take you back to the 1.1 lesson where we saw this whole equation. In 1.1 we learned the effect of h, which is to turn it left or to shape it left or right, k, which makes it go up or down. But in this lesson we're going to be learning the effect of a and b. So let's start off with a. A just tells basically whether your graph gets taller or shorter, and that tells it by the value of a. If the value of a is greater than 1, that means your graph is going to get taller. And if your value is in between 0 or 1, that means your graph is going to get shorter. But if you had a negative value for a, that means it's going to actually reflect over the x-axis. And for b, it tells whether the graph is going to get skinnier or fatter. But you got to be careful for b, because if you think about it logically, if you think if it's a higher value it'll get fatter, actually it's the opposite way. If you had a value more than 1, it would actually get skinnier, as you can see here. But if you had a value in between 0 and 1, it would actually get fatter. And if you had a negative b value, it would go flip over the y-axis instead. So we start off with y equals negative f of x. The negative will tell us if it's a reflection. And since it's the negative and it's outside the bracket, that tells us it's a reflection over the x-axis. And the only difference for the second blank star here is just that the negative is inside the bracket, which tells that it's a reflection again, but it's a reflection over the y-axis instead. So here's some practice problems. We have our original graph, and it says you have to change according to the transformation, y equals negative f of x, which is basically a reflection over the x-axis, and it'll look like that. All that means is the x-axis is the mirror, and whatever points are below it goes above, and vice versa. So since this was at negative 1, it would go up to positive 1. Since this was at 2, it would go down to negative 2. Since this was at negative 1, it would go up to positive 1. And for f of negative x, it's the same thing except you're reflecting over the y-axis instead, and it'll look like that. So you're using the y-axis as your mirror, and whatever points are left to it will go to the right, and whatever points are to the right of it will go to the left. Now now this is an example of a stretch. Since it's outside, this is the a value 3, which means it's a vertical stretch. So it's either going to get taller or shorter depending on the number. Since it's greater than 1, this means it's going to get taller. All that means is you're going to multiply your y values of the points by 3. So we started off with 0, 0, and this point is at a y value of negative 2. Since it's 3f of x, you're just going to multiply your y values by 2, and it'll come down to negative 6. Since this is at negative 4, it'll come down all the way to negative 12, and all the points are also multiplied by 3, and it'll look like that. The final point is kind of off the graph, so that's why it's not shown. And this is a fractional value in between 1 and 0. That means that it's going to get shorter, not taller. So again, you have the same points. It's at negative 2 y value. Instead of multiplying it by 3, you're just going to multiply it by a half. So it'll come into negative 1. Since this is a y value of negative 4, it'll come into negative 2, and so on. And it'll get shorter. Now that we've done some vertical stretches, now we're going to move on to some horizontal stretches. As I said with horizontal stretches, if it's a value more than 1, it's going to get skinnier, not fatter. So we have our x values here. It's at negative 2, and it's going to get skinnier, so you'll have to divide it by 2, so it'll come into 1. So it'll come over here. And since this is at negative 4, and you divide it by 2, it'll come into negative 2, and all the points so on will look like that. And since it's f of 1/2 x, that actually means you're multiplying your x values by 2. So it'll actually get fatter like that. Now we're showing a word problem where you have to put in all the transformations and make it look like y equals AF and then in brackets b times x. And I'll show you the answer and I'll explain why it's the answer. That is the final answer, y equals 3f of negative 4x. That's the answer because first we're starting off with a vertical expansion by a factor of 3. That means it's going to get taller by a factor of 3. That's why we gave the a value 3. The horizontal factor is getting compressed by a quarter. That means it's getting skinnier. And we know when it gets skinny, it has to be a value above 1. So that's why we gave it a value of 4 and not a quarter. So you have to be careful with that. And since it's reflected over the y-axis, you have to give it a negative value. So instead of 4, it'll be negative 4. For this question, we're given a basic graph and we're asked to draw the transformation. So how we do that is we take each individual point and then we do all the transformations for it. So nothing will happen when you vertically expand this because it's at 0. So if you multiply it by 3, nothing will happen. But if you divide it by 2, it'll go in. It'll go into negative 2. And nothing will happen if you horizontally compress or expand this because it's at 0. But if you vertically expand it by a factor of 3, it'll go all the way to 9. And the same, and for this, if you divide it by 2, it'll come into 3, and that's how your final graph looks like. And that's it for chapter 1.2.